Hello, and if you don't know already, I'm Florence, and welcome to the re-recording of the latest science news that's been going on. I was re-recording because after 25 minutes of recording last time, my camera crashed and nothing was saved. The true signs of a small YouTuber, so roll the intro. I'm going to be talking about three things from the news, one of which will have happened by now, and that is the first Chinese woman to go to space. The next thing will be about parallel worlds, and finally I'll be talking about something happening at the edge of our solar system. Now, this first Chinese woman into space at the time of recording is going to be happening tomorrow, but it will have happened by now, and that first woman is 33-year-old fighter pilot Liu Yang. And she'll be making her way with two other astronauts to the Chinese space station module called Tiangong-1, which translated means Heavenly Place 1. And this module is currently being used for scientific experiments, and by 2020 they plan for this station to be much larger, basically picking up from where America has now left off. And also the name Heavenly Place is much better than the Americans' International Space Station, in my opinion. And she's been quoted on many things, but my favourite quote from her that I've come across is, "I believe in persevering. If you persevere, success lies ahead of you." Now, I was way ahead of the bullet previously about this because I talked about it way back in February of this year, which you can link to in this annotation or down in the description below. Next up, it's neutrons escaping into a parallel world. And this has come from two theoretical physicists who I'm not happy about having to try and pronounce their names again, but they are called Zurab Bereziani and Fabrizio Nesti. And these theoretical physicists were from the University L'Aquila in Italy. And they were analysing data from Institut Langerin in France, again something I've probably mispronounced. And the leader of the research group who was looking into that was called Anatoly Serebrov. And basically what they found was the rate of loss of some very slow moving free neutrons was related to the strength and direction of a magnetic field imposed on them. Now, you may be thinking that neutrons don't interact at all with a magnetic field since they've got no charge, but they do have a magnetic moment, which is basically the movements of charge within them, because neutrons are made out of quarks. Now, the Italian physicist, whose name I'm not going to repeat again, hypothesized that these neutrons are oscillating between a parallel world with mirror particles, and the probability is related to the magnetic field. And they worked out that this could happen to the neutrons within a couple of seconds rather than the standard decay time of a free neutron, which is about 10 minutes, which I talked about last week when talking about radioactive decay. So either click the annotation or the link in the description down below to go to it. Now, the condition that this has though is that the Earth must have a mirror magnetic field of 0.1 Gauss, and the way that this could be possible is it could be caused by the mirror particles moving about in our galaxy, one possible candidate for which is dark matter. Now finally, something a bit less complicated, it's Voyager 1, and if you don't know already, Voyager 1 and 2 were launched in 1977, and they were originally sent out to look at the rings of Saturn and Jupiter, but ended up looking at all of the gas giants and are still making their way out of the galaxy. Voyager 1 is the one that's furthest ahead, and to get an idea of quite how far they've travelled in that time, they passed Saturn back in 1980. Currently, Voyager 1 is travelling at about 17 kilometres every second, which is about 3,800 miles an hour. And it's currently about 18 billion kilometres away, which is about 11 billion miles. And it takes 16.5 hours for the signal just to get to us. Now, recently has been detecting a large rise in the number of high-energy particles from distant exploded stars, or supernovas. There has been a steady rise of these high-energy particles that have been recorded over the last 3 years from Voyager 1, but this has been a rather sharp increase. Now, what tends to happen is the sun's solar wind interacts with the interstellar wind and kind of acts like a solar system shield for us. Now, data is constantly coming in from it, but that will only be happening for about 10 to 15 more years, because after that time, Voyager's plutonium power source is going to run out, and that means that we won't be receiving any more data, nor will it record anymore. That's all for now, and thanks for watching. I only have 2 more exams to go, so after that I should have more time to do these videos. But thanks for watching, remember to subscribe, like and comment down below, and I will see you next time.